You know, it's the bounding by, so it's wherever they first started at the time.
So we got through page 1 through 11. Any questions about any of the problems that you want me to go over with you? Page 1 through 11. Oh, good.
Did you know on page 5?
This one here.
Yeah.
Okay, so this is number 3, page 5. We have base of a triangle is increasing, and then also height is also changing. So area of a triangle is 1/2 base times height. We got to go through a product rule to build our derivative. So f prime g plus f prime. We know dv dt is +3. We know dh dt is -3. So this is as far as we can get in terms of dh dt. So we have to kind of play around with different numbers here. We don't know what h and b are, but can we come up with a scenario that will always be true, no matter what h and b are? So a is always increasing. That's not true if my b is larger, because the dh will be negative. A is always decreasing. That's not true if h is always positive. So the only one that's going to be true is when b is greater than h, we can guarantee that a is decreasing. Because when b is greater than h, this is going to be a larger value, which will force this negative, which will force that to be negative, which is a is decreasing. Yeah, we can decrease some stuff with that. Nice. You put your phone on 36. Let's see what this is. Any other questions? Page 1 through 11. Okay, so starting page 12, let's work through the odds, and then I will show the answers as you guys get to each of them. So 15, we start off with cross section. So with cross section problems, you're always told which direction to build your base length. So in this case, for 15, we're building our base length vertically. So top minus bottom. And There is no circle. It's not a disk method or washer method, so there's no rotation going on. So our area has no pi involvement except for the bounds. It's in terms of pi, but our area is just base squared. So remember your integral for your cross section is just the integral of the area squared. Or sorry, yeah, integral of the area. We only attach pi for disk method, washer method, and one cross section is semicircles. That's the only one that's going to show up involving pi as a coefficient. Our equation has a shaded region that is right up against that axis of revolution. So it's going to be this method. Only one radius is required. However, our radius has to be horizontal because our axis is vertical. So if we see a horizontal, you got to do right minus left. If you want to do right minus left, everything's in terms of y. Your radius is in terms of y. Your bounds are in terms of y. And then once you set it up, the rest goes in your calculator.
The pi on the outside, we only take it off whenever it like specifically states it's like a square cross section.
Or triangle cross section or trapezoid or yeah, basically any cross section except for semicircle has no pi in it.
And then we just do it without the pi.
Yeah, there's no pi. Yeah, we only have pi if there's some sort of a circle related shape within the cross section.
And then like for a triangle or like a trapezoid, we'll just do it normally, like without the pi.
Exactly. Right. The only cross section is semicircle. That's the only one. There's a pi over 8 in front of the area, in front of the base squared. If you're good with 13, go to page, sorry, if you're good with 12, go to page 13. These are the problems that derivative inverse at a point. We've got to create our chart, move our way around that chart until we have enough data on the function side. And then we know the slope on the function side is always going to be the reciprocal of the slope that we're looking for. So just do the reciprocal, don't do the opposite reciprocal.
Is it? It's big R minus level R, but So is big R the top or the right function?
It's it's the one with a larger radius. Yeah. Yeah. So for instance, if I had a problem like this. Let's say this is y equals cube root of square root of x. This is y is equal to x cubed. This is a shaded region here. That's big R. And this is big R. Big R is longer than so for number one, on page 13, we start off knowing that the x value they give you is not really the x value of the function, it's really the y value of the function. And we set the y value equal to the original function. We solve for x. We get three solutions, which means that, okay, there may be three possibilities, but then we're only looking for the one that's going to fit our criteria here. So if I can find f prime of 0, f prime of 1, and f prime of -1, I can look at my options and then flip all of these and see which one is going to fit. So f prime of 0 is -1. The reciprocal of that is -1, so that doesn't show up. I know that can't be it. The other two options are at 2, so if I flip 2, I get 1/2, so 1/2 is the slope that I'm looking for. Let me know if you have any questions, any problems along the way. I can go through any problem you want me to go over. If you go with page 13, go to page 14. Yeah. Yeah, so you do math 9. Let's say I want to do integral from 0 to 4 x squared minus x dx. Your math 9 will take 4 arguments, the function, comma, x, comma, lower bound, comma, upper bound. Mhm. Yeah, you do comma x, comma 0, comma, so no parentheses. Okay, yeah, so don't put parentheses around all these, just put commas around them.
And where's the comma?
Oh,
Just above 7.
yeah, above 7, yeah. X.
Oh,
Oh, right here. Remember, you're always building your slope at the center first, and at the very end, you plug the -1. You're trying to find, the change line slope at 0.
It's revolved around. So everything is like. I'll show you those things. Just. Easier. Watch. It would be this. That's the project. So my breaking. Into the one square. Oh,
I guess I'll check this. I remember doing this.
Yeah. Just had that yesterday.
Dude, I remember. No, the first problem, I could do it. The second one, I had
Yeah,
no
no
idea,
idea.
and I was freaking out for the rest of it, and I just sat there and had snacks.
Good. You play the afternoon games?
Huh?
You play the afternoon games? We had like
Oh,
games and stuff towards the,
I didn't remember that.
Of the games.
It was just a test for me.
okay.
Like after the tournament, there were.
Yeah, we had all these, we had all these games.
Oh wow. Okay.
But maybe, okay, so one font, we can finish this one.
Oh,
Show it to me.
Implicit, so do that,
Yeah.
my final one, and I'll come around and check that. Okay.
Fine. If you're good with page 14, then go to page 15.
Yes, sir.
Everybody okay with 1? Oh, for number 2, I mean?
Yeah.
So, the Y wasn't provided for us. So we actually had to go and look for that Y value. So we know X is 1. So I had to plug 1 in for X and actually look for that Y value before I can plug in and at the end to find my slope.
Yeah.
Thanks. Okay, everybody good with page 15? We go with 15, go to page 16. I'm just having us pace through the odd number problems. If you want to do evens, that's fine. And also that's good for this for later today as well, if you want to get additional practice and go through the even number problems. But I'm only going to be checking for the odds. Okay, page 17.
Oh, sorry. Washington. Where's that? It's big R. Yeah. Yeah, make sure they're both square individually. Got it. Oh, yes. This is the calculator.
Yeah. Without.
Yeah.
As I knew, so on, to get beta for this.
Or you can set all the sequences and then graph it with the x-intercept.
Should be able to use. What should be. Like, oh, we could give. Are you number 6 on 7?
Oh, this is meant to be calculator. Yeah. Yeah, so, yeah, anytime you see like a strange decimal value, that's meant to be calculated question. So I will set them equal to each other, bring everything over to one side, graph whatever you want to graph and look for the x-intercept. That's a way to look for your x-intercept. X-intercept is your solution.
Okay, why did the there's separation?
Oh, well, we could do this. We could graph this and graph that and look for the intersection. But I find it easier to just bring everything over to one side and graph this and look for the x-intercept. That way you're not searching all over the place for, where these two random graphs are intersecting.
Okay, I can just, because I got there, but I was just wondering, like, am I even like supposed to like just put it in -1? So I can just like put the whole function over -1 and it'll work.
Oh, it's
Like, as cash as you go -1. So then I just get the index.
Yeah. I mean, it's up to you. I mean, you could graph both of these separately, but this is the way I do it.
Yeah.
So it's up to you. There's more than one way to do it. Okay, so your homework is to finish pages 12 through 22, odds, but I won't check it tomorrow. You guys will be taking your test tomorrow. 15 questions, multiple choice. And you can use your calculator, but I'll be asking you to show your work for problems that are non-calculator problems. Okay, all right, go get your phones.
Calculator and non-calculator.
No. Within the test, there's calculator and non-calculator sections, but you get to use calculator on everything. But
Oh,
on the
like,
non-calculator section problems, I'm gonna ask you to show your steps, like I said, if you didn't have a calculator.
yeah.
Yeah.
Like non-calculator.
Because the AP multiple choice tests you have like two different, you have two different.
Yeah.
Do they go as one test or do they go as two separate tests?
You mean on the exam?
No, on the.
Oh, yeah, these will go together as one test grade. And this will be 50 points. And the homework is about. We'll do everything in terms of X. No. You'll.
Yeah.
No, okay. Do the
Maybe do you have stuff?
function.
Do you have that? What you can chat. Let's do. Go to the wall and give it a place.
Right.
Why are we doing next check?
Oh, yeah.
Finish up.
Okay, yeah.
Just be the once again.
For, I think the reason I'm working on for Friday steps, in fact, five is the, race. Take on. Oh, no.
Are you able to go ahead and check?
Oh, you're getting.
When it stops working. That's not working.
Yeah, that's real.
It's like, if, or unless.
No, that's super old. That's what we do as a thing. We just upgrade. I think it's what's the become
Also, when. So it's crazy out there.
yeah, from I built sixes. Six plus. I really just to my dad went to a my mom went to a 12 Pro Max and my dad went to a
It's like, yes, sorry.
Yeah, my mom would have like this. Like the five, like I'm looking at like.
yeah.
My favorite was.
Oh, wait, so you're setting this equal to the derivative then.
Also, when you upgrade like.
You gotta set it, maybe like theorem, you're setting the slope equal to this, and then that should.
Okay.
Like it's 12 to 13. It's really I love it.
You need to come back and finish it?
Yeah, I have, it'll take me 5 minutes, I think. I have one question, if that's okay.
Yeah.
God, and that is a lot of noise.
Okay, thank you. All right.
Yeah, it was. Okay,
all right.
Thank you so much.
Yeah.
Said you were, wise. Space. I don't know what thing I have. Because you just did. I just really.
They'll be on it to be small.
Like, it's the pleasure of letting my eyes all around. No. I got it. This is the topic, the whole folder.
There's never gonna get it.
Actually,
No, really, I'm actually really interested in all that, like everything. I can't do it really hard. I did our sound resource. Everybody did, I know. Like, literally all the match. Except for the one came back, we started my own clips. I probably too.
Alright. It's like chilling.
I should not mind this. Actually, let's try us. Probably I should create a show.
That's so fun. I feel hard with Heather.
Yeah, Louis. Yeah, sure.
Now,
This could shoot. Just so see. It'll take like 6 years.
yeah, I'm gonna put this.